Hey guys, I'm Jade. Today is my LeetCode review vlog on the 100th problem, same tree. We are given the rules up to binary tree, P and Q. We have to write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical, and the nodes have the same value. Let's example 1 here to understand it easily. We got two binary trees. Their root nodes are both 1, and their left child nodes are both 2, and their right child nodes are both 3. All the nodes are identical, so they are the same. We just return true. But for example 2 here, the first binary tree only got one left child node, but the second binary tree only got one right child node, so they are not the same. We just return false. Then let's get started with our intuition to solve the problem. And there are two approaches. The first approach would call recursive depth first search, and the second approach called iterative breadth first search. Let's start it by the first approach. And the main idea to compare the two binary trees node is node by node. And there are 4 steps we have to check. First, if both nodes from the both trees are null, and they are considered the same. But if one node is null, but the another node is not null, the trees are not the same. We just return false. And for the third case, if both nodes are not null, then we'll compare their values, and we'll recursively check the left subtree and the right subtree until the end. Next, let's get started with our code to solve the problem. So the very first step, we have to check if both nodes are null, if P equals null and Q equals null. Then we just return true. And for the second check, if one node is null and the other node is not null, they are not the same. And the code is if P equals null or Q equals null, we'll return false. And for the third case, if they are both not null, we'll check their values. If P dot value is not equal to Q dot value, we also return false. And then we have to recursively check the left subtree and the right subtree. Return, and we have to reuse the same function, the same method, is same tree method. Same tree, and the first parameter is the left subtree, and the code is P dot left. And the second parameter, it is the subtree from the Q pointer, Q dot left. And we also have to check if their right subtree are the same, so we have to reuse the method again. If same tree, P dot right and Q dot right. And that's all of the code for the first approach. Recursive depth first search. Then let's analyze their time and space complexity. So the time complexity, it is big O of n, and n stands for the number of nodes in the subtree, as we visit every node in the subtree for only one time. And the space complexity, it is big O of h, and h stands for the height of the tree. This is because we have used those space for the recursion stack. And in the worst case, the height of the tree can be n. For example, if the binary tree is an unbalanced tree. And in the base case, it could be log n, because if the tree is a balanced tree. So h is between n to log n. And this is only first approach. Next, let's get into the second approach. Public Boolean Eccentricity. Version 2, tree node P and tree node Q. And for the second approach, we'll call it iterative breadth first search. And the detailed step is we'll use two queues to perform a level order traversal. And inside the traversal, we'll compare nodes level by level. Then let's get started with the code and annotations for the second approach. First, we'll create two queues. Queue of tree nodes, and the first queue equals a new linked list. And then is the second queue with another new linked list. Next, we'll add the two root nodes of both trees to their respective queues. Let's say Q1 offer the root node P, and Q2 offer the root node Q. Next, we have to process nodes while both queues are not empty. While Q1 dot is not empty and Q2 is also not empty. And inside the while loop, first we have to retrieve nodes from both queues at the corresponding position. Tree node 1 from the first binary tree, Q1 dot poll. And it's very similar for the second node. Node 2 equals Q2 dot poll. Next, if both nodes are null, we'll continue to the next pair of node. If node 1 equals null and node 2 equals null, we'll continue the while loop. Then we have to check if one node is null or the other is not. Then they are not the same. We just return false. If node 1 equals null or node 2 equals null, they are not the same. So we just return false. And for the third condition, we'll compare their values. If they are not the same, we also return false. If node 1 dot value is not equal to node 2 dot value, we'll return false again. Then, if both nodes aren't null, we'll add, and their value are same, we'll add the left and right children of both nodes to their respective queues to prepare for their subsequent iteration. And code is Q1 dot offer of node dot left and also node dot right. And it's very similar for the Q2 to do so. Q2 would offer the node dot left, node 2 dot left. 1, node 2 dot left. And out of the while loop, then we have to check if both queues are empty. If so, both two trees are the same. And this is the final check. Return Q1 dot is empty and Q2 should also be empty. If so, we just return true. And that's all the code for the second approach. Let's analyze their time and space complexity. And the time complexity is very similar. It is big O of n2. And n stands for the number of nodes in the tree, as we just visit every node for only one time. And the space complexity could be worse. It is big O of n. This is because we use it for the queue storage. And in the worst case, the queue could store all the nodes at the last level of the sub-binary tree. So, and their time complexity, it is big O of n. Then let's submit code to check for the first approach. Oops, we have to revise the code and submit again. Node2.value, we have to correct it. Value is on the 36th. Then let me check it again. Yes, our first approach got accepted. Then I'm going to check for the second approach. Is symmetry is here. Let me check it again. Yes, our second approach got accepted too. And this is the end of my LeetCode review vlog on the symmetry problem. And I highly recommend you guys to visit my online GitHub page here, which contains all the nodes for the top 150 LeetCode problems. And for each problem, you can see problem description, intuition, Java code with annotations, and the final time and space complexity analysis. You can also visit my GitHub repository here, which contains the codes and nodes to build this online GitHub page. And I'll put those two links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.